Hi, I'm Dwayne, developer advocate at GitGuardian. In this video, we're deep diving into ggshield, the command line interface from GitGuardian that extends the power of the platform right into your terminal. In this video, we'll walk you through installing and authenticating ggshield, exploring all the different ways you can scan code, containers, and other sources, set up secret scanning inside a CI pipeline. We'll also go over using install to set up a pre-commit and pre-push hook. And finally, we'll look at HasMySecretLeaked and Honeytokens. This walkthrough assumes you already have Python and Git installed locally and a GitGuardian account. We won't be covering those steps here, but we'll link to the appropriate resources in the description below. While ggshield itself is open source, the tool does require API access to the GitGuardian platform in order to perform scans and manage Honeytokens. Let's get started. Let's begin with installation. You have a number of different paths here, depending on which system you're using. For Mac users, you can install through Homebrew, or you can download and install a standalone .pkg package from the ggshield release page. This package does not require installing Python, but it does require you to manually download new versions. Linux users can install using deb and rpm packages, which are available on Cloudsmith. Windows users can install ggshield via the Chocolatey Package Manager, or through a standalone .zip archive from the ggshield release page. This archive does not require installing Python, but you do have to manually download new versions. GitGuardian also offers a pre-built Docker image if you prefer working in containerized environments. But the most common way to install ggshield, both locally and in CI environments, is with pipx. Pipx installs ggshield in an isolated environment. You can install it with the command pipx install ggshield. That's all it takes, and you'll have the latest version ready to use. Once it's installed, confirm it's available by running ggshield -- version. You should see the current version number. If you do, you're ready to move ahead. Now that it's installed, we need to authenticate ggshield with GitGuardian. We'll do that with ggshield auth login. This opens your browser to sign in through the GitGuardian dashboard. This path automatically generates a token on your behalf and safely stores it locally via config. By default, this created token will allow you to scan for secrets, which is the most common use case. We'll revisit scopes later. Alternatively, you can use a locally stored token to authenticate. This can be generated from inside your GitGuardian workspace. To use a token, you can run ggshield auth login -- method token and then paste your key. Note, if you're using the on-prem version of GitGuardian, you'll need to use the instance option and supply the URL. Check with your administrator on the appropriate URL for your GitGuardian instance. To confirm we're authenticated, let's check and see if we can reach the API. To do that, we'll run ggshield API-status. If you're not logged in, you'll see an error that says no token is saved for this instance. If you are logged in, you'll see a status message that shows the health of the service and where the API key is stored. By default, this is in user config. If you ever need to log out of ggshield, simply run ggshield auth logout. If you used the web browser to log in, this command will invalidate the access token on GitGuardian as well. If you want to jump straight to scanning a path or repository, you can use the chapters in the description of this video to jump to that section. Otherwise, we're going to take a closer look at the tool itself. Let's pull up the top-level help menu by simply typing ggshield and hitting enter, with no other options or commands. To leverage the robust help menu at any time or for any command or option, simply type the command in question and add a -h or a -- help before you hit enter. ggshield follows a standard command line pattern you'll see in many tools. The name of the tool, option, command, argument. If you're new to command line interfaces, it breaks down as this. ggshield is the program you're running. Options are switches you can turn off or on to change how the program behaves globally. The command is what you actually want ggshield to do, like secret scan a file, repo, or commit. Args, or arguments, are the extra bits of information that the command needs to execute, for example, a path or a file name. The next thing that the ggshield help menus will always show us are the global options. These control the environment of ggshield, not the actual scanning. Think of them as the setup switches you can use at any time, no matter which command you're running. While we'll not be covering every single possible way to use all of these options, it's still a good idea to be aware of what these generally allow. -C or -config-path lets you point ggshield to a specific configuration file if needed. By default, ggshield will automatically check whether a new version is available upon every run. You can modify this behavior by using the options -no-check-4-updates or turn it back on with -check-4-updates. This is especially handy to know when you're working in CI environments. -insecure is a very dangerous option that bypasses normal security certificate validation checks. This is an option to avoid unless you're testing an on-prem installation or you're following your team's very explicit instructions. -log-file and then naming a file lets you save all logs the tool prints into that specific file. -debug sends detailed debugging information to your screen. And using the options -v or -verbose turns on a more detailed display mode so you can see extra context. Below these global options, we see our available commands. A few of these we've actually already used to authenticate and show the API status. And a couple of these others here in the top level help menu are purely administrative. Let's briefly cover those now. ggshield quota checks the remaining quota of API calls available for your workspace. Currently, the starter plan gets 10,000 calls a month, and all business and enterprise plans start with 100,000 calls a month. Next, let's take a very quick look at ggshield config. This is the control panel for the CLI. It uses YAML to tell ggshield how to behave and can be tuned per repository. You can view the settings, you can set or unset keys, you can scope them either globally at the user level or locally at the repo level. Local config wins over global, and command line flags override both. If needed, this is where you can define the GitGuardian instance URL in case you're using a self-hosted version. We won't be going through every option here, but it's good to understand you can control many aspects of the CLI from config. We'll come back to HMSL, which stands for HasMySecretLeaked, Honeytoken, and install later on in the video. For now, let's move on to the heart of ggshield. ggshield secret. ggshield secret has two subcommands, ignore and scan. Ignore will make more sense after we see scan in action, so let's start there. ggshield secret scan can scan practically anything throughout the development lifecycle, so long as there's text involved. This includes PyPI packages and Docker images, as essentially they're just compressed layers of code, which ggshield is programmed to unwrap and analyze. Let's enter ggshield secret scan -h to bring up all the options for targets we can scan and go over each. The two most commonly used ones, and the ones we'll start with, are repo and path. Let's start with ggshield secret scan repo. This scans the entire repository, including all commits and branches. This catches any secrets hiding deep in your Git history. This is rather a thorough scan though, and can take some time depending on the size of your repo. This is a perfect command to use for auditing, especially before a release or when onboarding legacy code. You can scan code local to your machine or in a remote repo. Let's start with a local scan. I'm going to scan the repo for the folder that I'm currently working in. So I would run ggshield secret scan repo period, where period is the self-referential dot. Or I could specify the full path, which in this case would be ggshield secret scan repo /users /username /documents /repo name. But secret scan repo can also scan any remote repositories that you can reach. Let's test this by scanning the public ggshield repo on GitHub, which is found at github.com/gitguardian/ggshield.git. As you can see, this takes some time as there are thousands of commits to scan through. More often though, working locally, you'll be mostly concerned with only the most recent changes at the top layer, such as right before making a commit. That's where ggshield secret scan path comes in. This looks at the files and folders without considering Git history. The most common option you'll need with path is -r, which is the same as --recursive. That will let ggshield look through subfolders contained in the directory. The tool will remind you when this is needed. So, to scan the current directory, I could use ggshield secret scan path -r and the self-referential dot. Again, that's the same as specifying the full qualified path to that directory. Running this command will surface any and all secrets found in the files, and sometimes though, you don't want to scan the whole folder and just want to scan the changes you made since the last commit. That's where ggshield secret scan changes comes in. This checks what's about to be committed, catching new secrets before they get committed. ggshield also lets you specify just a range of commits to scan using ggshield secret scan commit range, and then defining the range. For example, if you want to scan just the last 10 commits, you could specify head -10 ... head. You can also use the commit hashes separated by the ... to indicate the range. This is very useful for investigating recent merges or pull requests, and it's a favorite command during incident reviews and audit cycles. Next up is archive scan, where ggshield can scan any zip or tar file with ggshield secret scan archive and then a path to that archive. ggshield will unpack and scan the files inside, revealing secrets that might be buried in archive releases. ggshield can also scan Docker images for hard-coded secrets inside layers or environment variables. Running ggshield secret scan Docker and then the Docker image name or path will first try to pull down the image if it's not already locally available. Docker must be running in order for this scan to work. This command is ideal for catching secrets embedded in container builds before pushing to the registry. It's also handy for keeping Docker images with plaintext secrets away from production. ggshield can natively scan for packages from PyPI, the Python package manager. ggshield secret scan PyPI and then list the package name will, under the hood, use the pip download command to download the Python package. This is a good way to stop dependencies with embedded plaintext secrets from getting into production. And for teams working with structured data via JSONL files, ggshield offers a docset scan option. Just ggshield secret scan docset and then a path to the file. Just to call out, there are 3 options that naturally go together off this list: pre-commit, pre-push, and pre-receive. We'll talk about these later when we get into Git hooks, where they're meant to be run with install. But that brings us to ggshield secret scan CI. This is not intended to be a locally run command. Instead, this one's for your continuous integration environments. It's designed to scan the set of pushed commits that triggered the CI pipeline build, be it from a new commit or a pull request. Setting up ggshield CI scanning is straightforward, and we officially support the following: Azure pipelines, Bitbucket pipelines, Circle CI, Drone CI, GitLab pipelines, GitHub Actions, Jenkins CI, and Travis CI. For today, we're going to look at using ggshield with GitHub Actions for our example. This will require authenticating to GitGuardian from within GitHub. To do this, we'll need to create a service account, or a personal access token, from the API section of your GitGuardian workspace. Service accounts are only available to anyone on a business plan or higher. For this demo, all we need is the scope of scan. It's a really good idea to have your tokens expire. Now, how long it lives will depend on your internal policies, but let's set this one to expire in 1 week. Add this API key to the getGuardian_API_key environment variable in your repo or project settings. For example, in this repo, I'll set it at Settings, Secrets, Actions. Finally, you'll add a new job to your GitHub workflow using the provided GitGuardian example scripts. We have example scripts available for all the supported providers. Okay, back to Git hook commands, which will actually bring us to ggshield install as well. Git hooks are the automation mechanism built into Git. When a certain event happens, such as a commit or a push, Git will check to see if certain files exist within the .git/hooks folder. For example, if there's a file exactly named pre-commit, Git will attempt to execute any commands scripted in that file right before a commit happens. For the 3 Git hook specific secret scan commands in ggshield, 2 of these, pre-commit and pre-push, are meant to be run locally on the developer's machine. Pre-receive, on the other hand, is done on the server side. Setting this up typically requires some advanced admin access and additional environments. So we're not going to be covering that one in this video, but you can check with your preferred repo hosting platform like GitHub or GitLab for more information about how to set up pre-receive hooks. The goals of the pre-commit and pre-push hook are to stop secrets from entering the Git commit history and to prevent developers from pushing any secrets to a shared repository. You can build your own hooks manually in the .git/hooks folder. For example, if you created a new file simply called pre-commit and filled it with the 2 lines that are on the screen now, once that file is saved, every time you go to make a commit, Git will invoke GitGuardian to scan the changes to the repo that you're trying to commit and throw an error if any secrets are found, stopping the commit from finishing. This command of pre-commit will also return information about the secret found, including the location of the code, validity, type of secret, and some other information. GitGuardian will also provide some helpful guidance on how to remediate the situation. This messaging is completely customizable from within the GitGuardian workspace. Pre-push simply does the same scan, but just later in the process. After the commit is made, but before the code leaves the local machine, stopping commits that made it into the code but might not have been authored by the developer. This is very useful when working directly with patches. But there's no need to write a pre-commit or pre-push hook by yourself. That's where ggshield install comes in. Rather than install the tool itself, ggshield install creates the specific Git hook, either for the current repository or for all repositories on the machine. There are 4 options for ggshield install. The first is the mandatory mode. It's a -m or -- mode, which you'll need to specify as either local or global. Local will only modify the .git/hooks folder inside the project where you're currently working. Global will set this hook for all repos across the user's machine by modifying the .git config file in the user's home directory. -t or --hook-type will let you specify which type of hook to install, either pre-commit or pre-push. The default is pre-commit. If you want to overwrite an existing Git hook, you can do that with -f or --force, but it's way more useful to use the append option, the -a or --append, which will simply add the needed ggshield secret scan call to the end of an existing pre-commit or pre-push script. And that covers it for ggshield secret scan. But what about ggshield secret ignore? This command adds ignored secrets to the secrets.ignored_matches section of your local configuration file. If no local config file is found, a new .gitguardian.yaml file will be created inside the project. You can use this with the option --name to specify the name of the secret to ignore, or more commonly, the option --last-found, which ignores all secrets found during the last scan. This is helpful for local testing where the secrets are not sensitive or they're invalid. So far, we've scanned files, repos, containers, and some other things with ggshield. But ggshield goes beyond that, and it can also help you track leaked credentials found out on public GitHub, and will help you detect live exposures through Honeytokens. Let's take a look at those commands next. Since 2018, GitGuardian has been scanning for secrets added to GitHub public repositories. When we find a secret, we hash it and store only a fingerprint of the secret on our platform. We have a database of millions of leaked secrets, and we allow individual users and organizations to search for matching fingerprints to verify if any of their secrets have leaked in public repositories, gists, and issues out on GitHub. We call this service HasMySecretLeaked, hence the ggshield command HMSL. There is a web interface, but we're going to stick to working with ggshield for this video. Let's take a quick look at the help menu for HMSL before we move on. Now in this video, we're not going to be going too deep through all the possible options, but just like before, we do need a high-level overview to see what's going on. There are a couple of administrative commands. Quota will give you the number of remaining search credits you have, and API status will make sure that the HasMySecretLeaked service is healthy. There are 2 paths for using HasMySecretLeaked with ggshield. The first uses 3 separate commands to understand what's going on under the hood. This is very customizable and will let you script your own solutions around it. The other way is to simply use ggshield's HMSL check that does everything all at once. Let's run through both scenarios to give you a better understanding of how HasMySecretLeaked works. First, we need to run the ggshield HMSL fingerprint and give it a path to a target file. This runs the standard hashing algorithm we use on found secrets to take a fingerprint of your secrets and produces an output file of payload.txt. Next, we'll use ggshield HMSL query to call the HasMySecretLeaked service with the payload to check if the fingerprints match any secrets we found publicly. When you run the query, By default, the returned payload will print to the standard output. It's a really good idea to write this to a file, as the decrypt command needs a path specified. Finally, we'll need to use ggshield HMSL decrypt to unencrypt the returned payload from GitGuardian, which is encrypted for security reasons. Or you can just run ggshield HMSL check and the path of the file you want to scan. ggshield performs all the same steps as before, just in one smooth motion, displaying the decrypted reply from GitGuardian in plain text right in your terminal. We do offer one advanced use case as well with HMSL. We allow you to check if any of the keys in your vault have been leaked. Currently, this is compatible with HashiCorp Vault KV Secrets Engine version 1 and version 2. GitGuardian offers a full integration with many enterprise secret managers, though. However, those integrations can only be administered via the GitGuardian workspace or direct API calls. And the last command we'll cover in this video is one that helps you achieve an active defensive posture: ggshield honeytoken. A honeytoken is a decoy secret that alerts you when someone or something tries to use it or validate it. This is kind of like a digital tripwire. In GitGuardian, you can create honeytokens through the dashboard or API. They look like real AWS keys because they are valid keys, but they do not allow any access whatsoever. They're also isolated to an AWS account that GitGuardian maintains exclusively for this use case. You'll need to manage honeytokens through the GitGuardian workspace or API, but ggshield allows you to create and hide honeytokens in your files. Before you can create honeytokens with ggshield, though, we need to talk about permissions and limits. As of the making of this video, using ggshield's honeytoken is restricted to users with manager or owner level permissions. Now, the good news, if you are using the starter plan for your personal work, you can create and manage up to 5 honeytokens. Also, when we first authenticated with the web authn flow via the browser, we, by default, created an API key with only the scope of scan. That's all we needed for everything up until this section. Now we'll need to broaden that scope to include honeytokens write and honeytokens read. There are 2 paths to achieving this. First is manually creating a new personal access token with the scan and honeytoken permissions, and then log in via ggshield auth login -- method token, and then paste your access token. The other path is to use the option -- scopes when using ggshield auth login. In this case, what we want to include is ggshield auth login -- scopes honeytokens : write. This will automatically include the honeytokens read permission, so we don't need to explicitly call that one out. Of course, if you are already logged in, you will need to log out of ggshield using ggshield auth logout before running any of those authorization steps. Now that we have the correct permissions, let's go ahead and create a honeytoken locally. There are 2 options, as you can see from the ggshield honeytoken help menu. First is create, which returns the decoy credentials directly to the terminal, as well as some metadata, such as where to find this honeytoken in your GitGuardian workspace. And create - with - context, which creates a realistic file containing a newly created honeytoken, making it look more credible to an attacker. For either option, you'll want to name your honeytoken to help you manage it inside of GitGuardian. You also must specify the type, which at this time is limited to AWS decoy credentials. Let's first create a honeytoken without context. All we need to give it is a type, but we highly recommend you also give it a name so it's easier to manage later. Here we'll enter ggshield honeytoken create -- name, and whatever name you want to give it, and then -- type AWS, and make sure AWS is capitalized. We see the expected output here, which includes the dashboard link, but there's also a recommendation to place it in one unique place. It's very important for honeytokens. Now let's create a honeytoken with context. So we'll enter ggshield honeytoken create - with - context. Again, we'll give it a name with -- name, calling it whatever you like, and then -- type AWS, remembering to make it all caps. If successful, the output will actually not show the honeytoken, but instead it will say that the honeytoken is created and placed in the following context: the file, which will show you the path to that file, and the language it was produced in. Optionally, you can set a short description and specify which language that the file will be written in. You can choose from almost any type of language extension you can think of. If you want to manually name the file yourself, you can do that, with the option -o or --output, and then supply the file name you want to use. It's important to note that honeytokens are meant to only ever be stored in private environments, such as private repos and internal platforms. Once publicly exposed, it's only a few moments before alarm bells are going to start going off to let you know that someone or something somewhere is attempting to use this secret. And that concludes our very thorough walkthrough of ggshield. We have covered a lot today, from installing and authenticating ggshield to running scans across repos, paths, archives, and containers. We've used ggshield inside of CI environments and in pre-commit and pre-push hooks with ggshield install. We've checked for exposures with HasMySecretLeaked and used honeytokens to set up defenses for unexpected secret use. The goal of ggshield is to empower developers to help keep secrets out of their code and repos while actively defending their projects and organizations. For more information on any topic we covered, please visit docs.gitguardian.com and simply search for ggshield. And check out GitGuardian's CLI GitHub repo for release notes and examples over on github.com/gitguardian/ggshield. If you found this walkthrough helpful, please give it a thumbs up, subscribe for more security-focused deep dives, and, as always, keep your secrets secret.